Hello everyone, welcome back. Here is VanAmsen, and today we are tackling a problem from LeetCode called Dota2 Senate. It's a medium difficulty problem and it's a fun one, especially if you are a fan of game Dota. So let's dive right into the problem statement. In the world of Dota 2, there are two parties, the Radiant and the Dire. The Dota2 Senate consists of senators from these parties. They want to decide on change in Dota 2 game, and the voting for this challenge is round-based procedure. So in each round, each senator can do one of two things. They can ban a senator rights, which make another senator lose all his rights in this and all the following rounds. Alternatively, if a senator finds that all the senators who still have the rights to vote are from the same party, they can announce the victory and decide on the change in the game. So we are given a string Senate representing each senator party affiliation. The characters R and D represent the Radiant party and the Dire party. If there are n senators, the size of the given string will be n, and the round-based procedure starts from the first senator to the last senator in the given order, and this will continue until the end of the voting. Any senator who have lost their rights will be skipped. So here is the catch. Every senator is smart and will play the best strategy for its own party, and our task is to predict which party will finally announce the victory and change the Dota 2 game, and the output should be either Radiant or Dire. And all right, so now that we understand the problem, let's think about how can we do this. So best is to use queue and simulate the process. So initialize queues for Radiant and Dire senators. So queue int Radiant Dire int n senate size and populate the queues with indices of the senators. So for int I less than n, increment if senate I is R, Radiant push I, else Dire push I. So simulate the round-based voting procedure while not Radiant empty and Dire not empty. So int R Radiant front and D Dire front. So we pop and Radiant pop and Dire pop as well. So ban the rights of the senator from the opposite party. If R less than D, Radiant push R plus N, else Dire push D plus N. So finally, predict the wins party. So return Radiant empty, Dire or Radiant. So this code simulates the round-based voting procedure and the script as described in the problem, and it uses two queues to keep track of the senators from the Radiant and the Dire parties. In each round, it computes and compares the indices of the senator at the front of the queue, the senator with the smaller index, so the one who gets to vote first, ban the right of the opposite senator from the opposing party, and this is implemented by not adding the losing senator back in the queue. So that's why we have position plus n to push it back to the queue with updated index. So their index in the next round, and the procedure continues until one of the queue is empty, which means that all senators from the losing party have lost their rights to vote. At this point, the function returns the winning party. So let's see if it's working for given test cases. Hopefully, yeah. So R ban D, and output is radiant. And if we have R D, so R bans D, and then D bans R, and yeah, Dire was left still. So it's a winning party. So now let's see how it's worked for unseen test cases. It's probably much bigger, but yeah, we have successfully passed the test, and it beat runtime 45% and 9 with respect to memory. So all is good, and I hope this video explained you how you can solve this kind of problems with Q and the simulation. And if you have any question, please leave a comment, and also please like, subscribe for more coding challenges, tutorials in C++. And as usual, keep practicing, and happy coding. See you next time.